And good morning, everybody. Today is the 4th of December 2020. The day is Friday. My name is Ferhan Mazher, and right now I am with the 10 Cambridge class. Today, our target is to study about the characteristics of sound, and very easy and very important also because these characteristics are tested in exams also. So, the first thing we are studying about the sound, and the first characteristic is the loudness. And the loudness means whenever you hear a sound, and the sound can be loud or it can be fainter. For example, if you are listening to a song and you have its volume control in your hand, the main volume control. And if you increase the volume, the thing which increases is basically the loudness, how loud the sensation of the sound in your ear. And if you increase the volume, that you are basically increasing the loudness. Okay. So loudness is basically a characteristic of sound by which we are able to distinguish between a loud and a faint sound noise. Okay, so you see when you talk very in a very low voice, that's your sound is faint, and when you talk like me, like I speak very loud, and so sound, the loudness of an object, uh, the loudness of a sound. Basically, it depends upon few factors, and you should know those factors. The first factor of the loudness is the amplitude of vibrating body. The sound from wherever the sound is being produced. So, whenever the sound is produced, the source of the sound always vibrates. And so, it's important the amplitude of the vibration that decides what will be the loudness of the sound. For example, I can give you an example that if you are listening to a song, you observe that the diaphragm of the speaker, that is vibrating. So when you are listening to music, if you look at the diaphragm of the speaker, you will observe that the speaker is vibrating. So from the mean position, how much he went to the left, and from the mean position, how much it went to the right, or from the mean position, how much it goes forward, or from the mean position, how much it goes backward, that is called the amplitude. Now increase the volume. Note down what was the amplitude before and now increase the volume. You will observe that the amplitude of the vibration of the diaphragm has increased. You see, if you will increase the volume, you will observe that the diaphragm of the speaker, now the amplitude of its vibration has increased. It will be now vibrating more distance forward and more distance backward. So the one very important factor about the loudness of a sound is the amplitude of the vibration of the body which is producing the sound. If its amplitude is smaller, it's only vibrating like little bit, it means that the sound will be faint. And if the vibration, the amplitude of the vibration is larger, then it means that the sound will be loud. Okay. So, and another factor on which the loudness depends is the area of the vibrating body. Okay. The area of the vibrating body, if the area of the vibrating body is larger, the loudness of the sound produced will be also, means the sound will be louder. If the area of the vibrating body is smaller, the sound produced will be fainter. For example, you might have observed that if you use smaller speakers whose diaphragm is very small, they produce not that loud sound. But if you bring speakers which have larger diaphragm, for example, this size speaker or this size speaker, the speaker with the larger diaphragm, their sound will be very, very loud. Okay? So the loudness of the sound depends upon these two factors. These factors are related. These factors are about the body which is producing the sound. One, the amplitude of the vibration of the body which is producing the sound. Second, the area of the vibrating body. The larger the area, the louder will be the sound. Another very important factor on which the loudness depends is the distance between you and the source of the sound. For example, if you have gone to a concert or if you have gone even to any function, if you will sit near the speakers, if you are sitting near the speakers, the loudness will be very high. The sound will be very louder. But if you sit away from the speakers, for example, you sit 2 meters away, or then you sit 10 meters away or 20 meters away from the speakers, then the loudness will become less. For example, while I am talking without a mic, for example, and if you are standing near to me, you will be able to hear a very loud sound. And if you are standing like 30 meters away and I am talking in my full loudness, the sound which you will receive, that will be not that loud. So this is also a very important factor, the distance from the vibrating body. If the distance from the vibrating body is smaller, the sound heard will be louder. And if the distance between the vibrating body, I mean the source of the sound, and the listener is larger, the sound heard will be fainter. So very important, these are the three factors. Another factor is the ear, the condition of the ear. You see, some people might not be able to hear that loudness, and some people's ears might be very sensitive to the loudness. Okay, so you can say the characteristic sound of different objects can be distinguished on the basis of different characteristics as described below. Loudness. Loudness is the characteristic of sound by which loud and faint sounds can be distinguished. When we talk to our friends, our voice is low, but when we address a public gathering, our voice is loud. Loudness of a sound depends upon a number of factors. Some of them are discussed below. The first one is the amplitude of the vibrating body. The loudness of sound varies directly with the amplitude of vibrating body. The sound produced by a sitar will be loud if we pluck its wires more violently. Similarly, when we beat a drum forcefully, the amplitude of its membrane increases and we hear a loud sound. The second factor is the area of the vibrating body. The loudness of the sound also depends upon the area of the vibrating body. For example, sound produced by a large drum is louder than that by a small one because of its large vibrating area. If we strike a tuning fork on a rubber pad, a feeble sound will be heard. But if the vibrating tuning fork is placed vertically on the surface of a bench, we will hear a louder sound. From this, we can conclude that the loudness increases with the area of the vibrating body and vice versa. The third factor is the distance from the vibrating body. Loudness of, yes, a loudness of sound also depends upon the distance of the vibrating body from the listener. It's caused by the decrease in amplitude due to increase in distance. Loudness also depends upon the physical conditions of the ear of the listener. A sound appears louder to a person with sensitive ears than to a person with defective ears. However, there is a characteristic of sound which does not depend upon the sensitivity of the ear of the listener and is called intensity of the sound. That's a different thing. That's not, intensity of the sound is not in our syllabus, okay? Another very important thing in O levels is this. Look at this thing. Let me increase the size and then you see this graph on your screen. Okay, this graph is very important. You should be able to understand this graph. This graph is between amplitude and time. This graph is between you can say displacement and time. This graph can be also between displacement and distance. So when I represent two sound waves, it's comparing two sound waves. And when I compare two sound waves, the important thing is how important thing when you are with regard to the loudness, we check what is the amplitude. Now, from the displacement time graph or from the displacement distance graph, you should know, okay, what is the amplitude. Amplitude is basically from this mean position. You can see this mean position on your screen, and from this mean position, how up you went. That's the amplitude. Or from the mean position, how down you came. That is called amplitude. And for example, this is another example of a sound. They are showing a sound wave. It might be the displacement time graph or it might be the displacement distance graph. In both the cases, from the mean, this black line represents the mean position of the sound wave. From the mean position, how high you went up, for example, this distance. From the mean position, how maximum you went up, that's the amplitude. Or you can say from the mean position, how down you go, that's the amplitude. So the loudness depends upon the amplitude. The sound whose amplitude is larger, the sound wave whose amplitude is larger will be louder. And the sound whose amplitude is smaller, that will be fainter. The opposite of the louder is fainter, okay? So from these two, the first and the second, if somebody asks you which one is fainter, so the second one is fainter. And why the second one is fainter? Because this graph shows that it has smaller amplitude as compared to the first one. And if somebody asks you which one is louder, so the first one is louder. And somebody asks you why you are saying this, because the first one, in the first one, we have a larger amplitude. And we know that the loudness of the sound depends upon the amplitude of its vibration. Gee, do you understand?
Yes, sir.
Yes, sir.
Yes. In O levels, it's very important that you should be able to recognize that which sound is loudest. For example, they might give you 4 options and they show these wave displacement and time graphs for a sound wave, and they ask you which one is the loudest, and then you should be able to understand, and you should know that the loudness depends upon the amplitude of the vibration, and on the graph where the amplitude is shown. G, is it good?
Yes, sir.
Okay. Okay, so let's move to another characteristic, very important characteristic. And from exam point of view, it is also very important. So here we go. The first characteristic of the sound which we have studied is the loudness. Okay. The second characteristics we are studying today is the pitch. We call it pitch. P-I-T-C-H. Pitch. Wherever the sound is produced, the sound will have certain frequency. For example, if you look at the tuning forks, their frequency is written on every tuning fork. The tuning forks which we have in the lab. And sometimes it is written the frequency is 120 hertz. On some tuning forks, it is written the frequency is 320 hertz. On some, it is written that the frequency is 420. So every sound has a different frequency. Now, another very important thing. For example, you can do this experiment also. If you have a bicycle and put this bicycle on a stand and rotate its pedals, so the rear wheel will start rotating. Try to understand this activity. So what you do, you take a bicycle, you make it stand on this stand, and then you start rotating your its pedals. Ask a friend to rotate its pedals, and the rear wheel will rotate. It will be revolving. Okay. Then take a plastic scale. Take a plastic scale and insert the plastic scale into the wires of the wheel. So the wheel is turning, and you have a plastic ruler which you have touched with the wires of that wheel. So you will hear a sound. Okay. Thus, you will hear a sound, obviously, when the ruler will touch those wires. Now, ask your friend to pedal faster and pay attention to the sound of that ruler, which is touching the wires of that tire. Then ask your friend to rotate the pedals faster and faster and faster, make them more fast, and pay attention to the sound which is produced. You will observe that as the tire rotates faster, the sound will become shrill. Before, the sound will be grave, and then the sound will become shrill. Grave in Urdu, grave means bhari awaz, bhari. And husky sound, And shrill means barik awaz. So what will happen? For example, if you normally this happens, the voice of male is grave, and the voice of female is shrill. So by that experiment, the speed of the tire decides that how many times that scale will vibrate. Frequency of the scale. Vibration, the frequency of the vibration depends upon how fast the tire is rotating. When the tire is slow, the frequency will be less. The vibration of the scale, the plastic scale, touching the wires of the tire. When the tire is rotating slowly, the frequency of the vibration of that plastic scale will be less. And the sound produced will be grave. When you start rotating the tire faster, the frequency of the vibration of that plastic scale, that will increase. And you will observe that the sound has become shrill. If you make it more faster, the frequency of the vibration of that scale will become larger and the sound will become shriller. More the frequency of the vibrating body, the shriller is its sound. If the frequency of the vibrating body is smaller, the sound will be grave. So you see, the graveness or the shrillness of the sound depends upon the frequency of the vibrating body. More the frequency, the sound will be shrill. If the frequency is less, the sound will be grave. So it means normally when male people they talk, their sound is grave, and the women they talk, their sound is normally shrill. So it means the frequency of the male sound is less, and the frequency of the female sounds, which is shrill, is more. So the sound can be shrill or it can be grave. Grave means less frequency, shrill means more frequency. So this characteristic of the sound, by which we are able to distinguish between a grave sound and a shrill sound, that characteristic is called pitch. And the pitch depends upon the frequency of the sound. If a sound has low pitch, when I say the low pitch, it means low frequency. And it means grave sound, bhari awaaz. And if I say a sound has high pitch, it means that the frequency of that sound is high. It means that the sound will be very shrill. So women, their sound has high frequency, their sound has high pitch, and their sound has a larger frequency. Men, on the other hand, normally their sound is low pitch, their sound has low frequency, so their sound is grave. Okay? So pitch is the characteristic of sound by which we can distinguish between a shrill and a grave sound. It depends upon the frequency. A higher pitch means a higher frequency, and vice versa. The frequency of the voice of ladies and children is higher than that of men. Therefore, the voice of ladies and children is shrill and of high pitch. The relationship between frequency and pitch is illustrated in the figure 11.8. So let me show you this diagram. Let me increase the size. In O levels, okay. in O levels, it's very important that you understand what is pitch and you have the ability to recognize the pitch from a displacement time graph. So here on your screen, you can see we have shown you two waves. Their displacement time graph is showing here. So these two waves, if you look at them carefully, they have the same amplitude. Can you see that? They have the same amplitude. From the mean position, the height of this wave, the amplitude, from the mean position, the height of this wave, the amplitude of this wave, they are same. So both the waves will have the same loudness, but they have a different thing. Here you see, from here to here, it represents time period. It represents time period. And you can clearly see the time period for this wave is larger and the time period for this wave is smaller. Frequency is reciprocal of the time period. Frequency is the reciprocal of the time period. F is equals to 1 by T. So the sound wave which has larger time period will have less frequency. And the wave which have smaller time period will have larger frequency. F is equals to 1 divided by T. F is, the frequency is reciprocal of the time period. So from these graphs which are showing on your screen, directly you can only find the time period. The time period is on the x-axis. So the time required to complete one wave, that's time period. So from the first wave, you can see the time period is larger. So its frequency will be smaller. In the second wave, the time period is smaller. So its frequency will be higher. So if somebody asks you which one is low pitch, the wave which is at the first number, the wave which is at the first number, it has low frequency, so it will have low pitch. The sound which is at the second sound wave, its time period is smaller, but it has a higher frequency. So this second sound wave will have higher pitch. It will be shrill. The upper one, which has low pitch, larger time period, low frequency, it will be grave. In your course, O-levels course, you know, the most important thing required about this topic is that you should be able to interpret a given displacement time graph of a sound wave and decide that which one has the higher frequency, which one has the higher pitch, which one has the lower pitch. So this is the main important aspect of this lecture, that you should be able to understand that how this graph is represented and how to read this graph and how to conclude from this graph that which sound wave has higher pitch and which sound wave has lower pitch. Gee, do you understand this thing?
Yes, sir.
So in our next lesson, we will do the amplitude regarding the topic of sound. Then we will test this thing also. But the most important thing is to understand the given graph. Okay, when we'll do MCQ, you will realize what I'm saying. So till now, we have talked about two characteristics. One is the and the loudness of the sound, and the other one is the pitch of the sound. Okay, now we move to the next third characteristic, very important characteristic in O-levels course. That is the quality of the sound. Quality of the sound is that whenever a sound is produced, so every complete wave of different sounds have different shapes. So every sound will have a different basic shape. Okay, so so one very important thing. Let's see this from another point of view. For example, if you are playing a song on guitar and the same song is being played on flute, and even if you are not able to see both the instruments, for example, you are sitting in another room and the music is played in another room. So when the song is played on a flute and when the song is played on a guitar, and if the same song is played on a violin, and if the same song is played on a piano, you will be able to distinguish, and you will be able to tell now that the song is played on a guitar. You are able to tell that this song is now being played on a violin. For example, we are able to recognize the sound. For example, if I am and another person, they are talking on the same loudness with the same frequency, even then, you will be able to distinguish that, okay, this voice is our teacher's voice and this voice is Madam Sadia's voice. We may be talking on the same loudness, we might be talking on the same pitch, but still you are able to distinguish that whose sound is this. This characteristic is basically due to the quality of the sound. Quality of the sound means that whenever any source of sound which produces sound, the waves which are produced, if you take a single wave which is produced, sound wave, take a single wave of the sounds of different sources which are playing the same song, same frequency, same loudness. You will observe if they have the same frequency, their time period will be same. If they have the same amplitude, if they have the same loudness, their amplitude will be same. But the basic shape of their wave, will be different from each other. For example, I can show you an example here. A very simple sound is of the tuning fork. Okay, now you can see. If you look at these waveforms, so look at, this is the time period of this wave and the time period of this wave. You can see that the time period is same. If all these three sound waves, they have the same time period, it means they have the same frequency. From the graph, I can only tell the time period. So if they have the same time period, these three sound waves, different sound waves, if their time period is same, it means their frequency is same. So their shrillness is same. Their pitch is same. Check out the amplitude. It has this much amplitude. This has this much amplitude. It has this much. So the amplitude is also same in these waveforms. The three waves, three different sounds, they have the same time period. It means they have the same frequency. They have the same pitch. They have the same amplitude. It means they are on the same loudness. They have the same loudness. Now look at another aspect. This is the sound of a tuning fork. Look at this graph. Look at this wave. Just take one wave, okay? This is complete one wave. This is complete one wave. Complete one wave. Look at the shape, the basic shape of the wave. And look at this complete. This sound is of the flute. So here it's the one wave is completed. Okay. If you look at this shape and this shape, their basic shape is little different from each other. So for example, it is very, very smooth. This shape is called sinusoidal. You know, this shape, this going down, up and down and up and down. This very smooth up and down, this is called sinusoidal wave. Its shape is perfectly sinusoidal. But look at the flute, it has the same pitch as the first one. It has the same loudness as the first one. But the basic shape of that wave is little different from the first one. Now look at this wave. This is from the clarinet. Its shape is also little different from the first two. So these three sounds, one is coming from the tuning fork, the other is coming from the flute, the other one is coming from the clarinet. They all have the same pitch. They all have the same loudness. But still you will be able to distinguish that this sound is from the tuning fork. You will be able to tell this song is from the flute and this song is coming from a clarinet. The reason is their basic shape of the wave is little different from each other. So that's why you are able to distinguish between these sounds, and you are able to tell that this sound is coming from a flute and this sound is coming from a piano. This characteristic is known as the quality of the sound. You understand? Do you understand?
Yes, sir.
Hello?
Yes,
Okay.
sir.
The characteristic of sound by which we can distinguish between two sounds of the same loudness and pitch is called quality. While standing outside a room, we can distinguish between the notes of a piano and a flute being played inside the room. This is due to the difference in the quality of these notes. Figure 11.9 shows the waveform of a sound produced by a tuning fork, flute, and clarinet. The loudness and the pitch of these three sounds are the same, but their waveforms are different. So their quality is different and they can be distinguished from each other. The next characteristic is called intensity of the sound. That is not included in your syllabus. But remember, because many people ask me this question, that why some sounds can be very dangerous for your ear. That is due to the intensity of the sound. That is not in your syllabus, okay? But you can, this is showing on your screen. This I will be saving this video also and uploading it in the YouTube also. So you will be able to read it, okay? So this was that's it from the characteristic of the sound. And another important characteristic was this one. But this is unfortunately not in your syllabus in sound intensity level. For that, we have the unit decibel. You will hear this word many times in your daily life, that the music of this decibel, the noise of this decibel, the pollution, air pollution is of this much decibel is the air pollution, okay? So, this is that experiment, okay? So, we are done with this experiment. And one very important thing is that in your I have uploaded videos in your Google Classroom, okay? So it's very important that you go in your Google Classroom and whatever is the order I have given, to see those videos. It's very, very, very important because we are moving faster. So it's very important to follow whatever the videos I'm uploading in your Google Classroom or on my YouTube channel. So you should be able to, uh, you are supposed to follow that, because this chapter we want to finish it in, and only one topic is left, that's ultrasound. We will do some numericals on the ultrasound and we will discuss it, and then this chapter will be over, and then we will practice its MCQs. So I think that it's enough for today, and I hope that you have understood. So have a good day and God bless you all. Thank you very much.